Hello, and welcome back to What's Up with Energy, a gridX podcast. I'm your host, Georgia Knapp, and today we are going to be talking about DSO signaling, EV charging, and a little bit of our favorite topic, 14A. Can't get away from it. And to discuss all of this with me is Akash, our product manager in e-mobility. So, Akash, thank you for joining me today.
Hi, Georgia. Thanks for inviting me for the podcast.
And I think just one note before we begin is that at gridX, we use a lot of acronyms. Whenever you or I say CPO, we only mean charge point operator.
Yep. The CPO term refers to mainly the charge point operators.
So just to get us started, I guess let's define what DSO signaling actually is and what DSO even stands for.
Yeah, maybe let's start with what's DSO. So within the energy market, there are different players. So there is, for example, the DSO, who is it stands for distribution system operator. Mm-hmm. And what do they do? So they basically are the ones who are operating, maintaining, and also expanding the electricity grid. And that's their main role, and they're the ones who are actually distributing the power to the end customer. So this could be homes, commercial spaces, or buildings, restaurants, any kind of end user who's consuming the energy. The DSO signaling is basically a communication that the DSO sends to the assets that are installed at the grid connection point, at the electricity grid of the DSO. And here it's basically the DSO employs this as a mechanism to ensure that they are able to send real-time control signals to these assets. So these assets could be, for example, PVs, batteries, charging stations, and so on, like all the big consumers. And by sending these kind of control signals, the DSO can basically ensure that the grid is not overloaded, not congested, and can be operated in a stable manner. So that's basically on a high level what the DSO control signaling is.
And so DSO signaling is increasingly becoming a regulatory requirement to open up new charging sites and locations. Why is this necessary, and what can CPOs do with this?
With the rapid deployment of EV charging infrastructure and assets, renewable assets like PVs and batteries, it's becoming really difficult for DSOs to manage the grid connection point and the stability of the network, because the loads are quite variable and unpredictable, and the EV infrastructure or the grid infrastructure is basically not designed for these kind of loads in the first place. And with the increasing number of assets like these being deployed, it is necessary for the DSO to ensure that they have some kind of a control to ensure at the end of it they can still manage these loads. And that being said, that's like the key necessity. And also with every new charging infrastructure that's being opened up, the DSO requests the CPO to ensure that they have these kind of control mechanism in place. And therefore, it is one of the key factors to even open up a new site. And it is a prerequisite, and the CPOs have to meet these grid requirements from the DSO to open up new sites. So therefore, it is critical that the CPO meets it. And about the second part of your question, how do they handle that? Or how do they meet these requirements? So I think that's where we as gridX step in, because for the CPO, the key focus or the business goal for them is to really focus on providing a good charging experience to their customers or the EV drivers. And secondly, also ensuring that they run a profitable business out of the charging service that they provide. So for us as at gridX, what we do is basically ensure that we provide not just a solution that is catering to the optimization of EV charging, but also at the same time catering to the need of meeting these regulatory requirements. So instead of the CPO trying to address or meet these regulatory requirements, we let them focus on what they see as most important, which is ensuring the charging experience, and secondly, making a profitable business out of it. and the whole regulatory requirement is more of an enabler. And we as gridX take that complexity away from them, and we provide a solution that is not just optimizing EVs, but also at the same time ensuring that we provide a solution that's compliant to these regulations, and eventually our CPOs can just continue to expand into different regions and markets and countries without thinking about the regulatory issues or the regulatory requirements which we would handle.
And then how does 14A play a part in all of this?
So the paragraph 14A, what does it tell us? So it ensures or it provides the opportunity for the DSO to control assets that can be controlled. And here we're only talking about active power control, and the 14A regulation tells us that charging sites that are in the private space or charging sites that are in the semi-public space, they have to be compliant to this regulation. And for example, these sites could be in a workplace charging, or for example, if you own an office building, then if there are parking lots with chargers, so this could be part of the 14A regulation, or restaurants where they also offer charging, hotels. So those kind of sites would be relevant for 14A. And so it ensures that the grid operator can send control signals via a standardized interface. And that's also one good thing about the 14A, because here they have a standardized interface to send these kind of signals. And we as gridX can receive these signals via our grid box that is locally connected at the grid connection point. And then we translate this into constraints and send them to the assets in real time, so that we can ensure that we are compliant to the signal that is being received from the DSO, and be able to also optimize the EV charging accordingly.
And then how did the customers that you work with respond to having to become 14A compliant? Or did you find you were having to educate people about it?
I would say it's a mix of both, because after the 14A came into place, we also looked into the regulation, implemented it, and we now have it as a stable feature that we can offer to our customers. And it really depends on the DSO, because once our CPO customers start to open up new sites, sometimes some DSOs do approach our customers to tell them that, okay, you'll have to now be 14A compliant. And when this is being enforced, then our customers also actively ask for it. But then on the other side, there are also CPOs who are opening up new sites where the DSO isn't really knocking their doors and asking for this. And at that point, it becomes something that is not super important at this point in time. But since it's a regulation that's in place, we see that more and more DSOs would be starting to ask for this. So right now, it's some do proactively ask for it, while some do not even know something like this is being requested by the DSO.
From a product perspective, what are the biggest challenges in sending and receiving these signals?
So there we have two main challenges that I foresee, and the first one here is basically the interface to how we receive these signals. So the actual constraints that they would be sending is active power control and reactive power control, and this is something that we can already do with the assets that we control, but the key problem lies in the interface and how it's being communicated to us or to the assets that are connected to the grid connection point. So that's one main challenge that we see. And the second one is also about how fast can we respond to these grid signals and be able to in real time apply and be able to also send a feedback to the DSO saying that we've complied to the signal that has been received and applied. So that's basically the two main challenges. And about the first challenge, I also wanted to get into a bit of detail there, because the standardization part of the interface is quite a problem that we have. For example, we were just talking about 14A, where we said there is a standardized interface. But then when it comes to public charging infrastructure, There, we do not have any kind of standardization, and each DSO has their own custom requirements for the signaling and how the interface should look like. And that makes it really difficult for us to provide a scalable solution that fits across a lot of DSOs. So maybe just to put that into perspective, let's say in Germany, we have about 800 to 900 odd DSOs. And in Austria, it's about 130 DSOs and so on. So, like now, to really be able to provide a custom solution for each DSO because they have their own requirements is really hard, and it becomes a project-based solution rather than a product-based solution. So we cannot really scale it, and that makes the whole thing difficult and takes a lot of lead time because we'll have to also see how we can develop or meet those requirements through development and then be able to test it and then eventually also roll it out. So that's our key challenge right now, and we're trying to meet or basically handle that challenge in different ways. So yeah, that's basically the challenges that I would see.
And then what about when it comes to the prioritization of the DSO signaling? How does an EMS, and obviously specifically our EMS, Xenon, handle the prioritization of that?
The CPO having the opportunity to use multiple different charging strategies that we provide, they can prioritize EVs depending on what they want to deploy. And here we're talking about how the power is shared across these chargers and the connected EVs. So here we're talking about the user-based prioritization, where we're considering the departure time and the state of charge that is required at the time of departure. And based on this, we then allocate the power accordingly. So there could be one EV that would like to leave earlier because it needs to, say, leave at 3 o'clock, whereas there's another EV that's leaving at 5. And looking at what the state of departure is at the time of plug-in and what's the target SOC for the EV to leave at the time of departure, we take that into account and then see which EV should get a higher priority, and based on that allocate power. So to answer that question, it basically depends on the site operator. So we offer a lot of different charging strategies to prioritize the EVs, and they can employ whichever suits their charging location better.
And is there a way to ensure that this flexibility does not compromise the user experience?
That's also something that we want to ensure to provide a good charging experience to the end EV driver.
Yeah.
So, for example, when there is a grid signaling, then we're basically trying to curtail the charging speed of an EV. And this would in turn lead to the EV driver who's connected seeing that the charging speeds are going down, and this would also lead to dissatisfaction because when the EV can charge at its full speed, just because there's a grid signal, they might have to it's automatically turned down, and this leads to further dissatisfaction. And to counter that, from our point of view, these kind of grid signaling should almost be invisible, in the sense that it should be unnoticeable for the end user in terms of not being impacted by it. And to do that, we are basically employing different kinds of methods. So one is to really see which EVs can stay longer and therefore can be deprioritized, to which EVs have to leave right away and therefore have to be prioritized. So that could be one thing. Or on the other side, we could also use batteries on site. If there is one, then being able to discharge this battery to ensure that the delta that we have from the grid limitation is basically tackled by the battery, which is then discharged to counter for the delta. And thereby, we are ensuring that the impact is not visible to the end EV driver, and thereby also ensuring that they have a good charging experience.
Are there any Are there any lessons from early deployments that have changed how you're building and refining your smart charging logic in response to DSO inputs?
Yeah. So we at gridX, we have an agile development approach where we're continuously learning from the field, gathering experiences, and then incorporating all of this into product development. And here, mainly with the DSO signaling topic, our key challenges, as we spoke about in terms of the standardized interface, that's one of the major challenges. And to tackle that, what we're also doing right now is employ a toolkit based approach. So what we're doing there is, instead of providing or trying to tailor a solution to each and every DSO requirement, we are focusing on trying to provide a scalable solution by having a toolkit that has a lot of different components in place. So then it's about basically putting them together and catering it out to our charging sites.
And then to shift gears a bit, unintentional pun since we're talking about EVs, we are starting to see large-scale batteries now at charging sites. From your view, what are the real advantages to this? Is it buffering grid signals, cutting peak loads, or something else?
I think it's kind of all of the above, because batteries, they basically provide an additional flexibility. And for example, the battery, once it's commissioned on a site, they can be used for multiple different things. So let's say they can be charging from the grid when the prices are cheap, or when there is surplus power, and then based on what they've charged, like the stored energy can then be used at time periods when there is peak demand. And so basically there are different use cases that we could do with a battery. And here, it really the possibilities are just huge. And right now we see a lot of charge point operators actually starting to deploy batteries. At least in the last 1 year, they've been really thinking about what the return on investment would be on the batteries, because the cost of these batteries are really huge. And with such kind of investment, they also want to really know what's the ROI on it and when could they actually break even. And that makes things really complex. And in the recent times, we've seen that after almost a year or so, or even more than that, of considering whether they want to deploy a battery on field, now they finally are going live with it. And we've seen in the recent times some of the charging sites having like the really large batteries. And once you have a battery on site, then I think the possibilities are really huge. So it really opens up a lot of different things.
Because when you add a battery, is that also when, because I've only read a few articles about this, but that's when you kind of turn the car park into a microgrid? Is that when we would use that term?
So basically, once you have a battery on site, then you can also go completely autonomous, because the thing with the battery is that the larger the size of the battery is, the better you can actually manage your own charging demands or the power demands at the location.
And what kind of logics or controls are needed to decide when to charge the battery, when to discharge it, or when to reserve the power?
Here, I think there are multiple factors and constraints that we take into account to be able to optimize the battery accordingly. And this starts with, for example, taking into account what's the current power or load consumption at the grid connection point. Then secondly, about the historical production or consumption pattern at the charging location. And we also taking into account PV forecast in case there is a PV on site. And finally, also, for example, if they have a dynamic tariff, then we're also taking that into account, and then be able to charge the battery or discharge the battery depending on the prices. And also finally, if there is a flex marketing, then we're also looking at flexibility, aggregation, and disaggregation. So depending on the use case, we can kind of take into account all of these different factors and then be able to optimize the battery depending on that. And pretty recently, we did launch a couple of high impact features that specifically focus on the battery. And that, for example, is the virtual grid expansion feature that was released at the beginning of this year. So what we did there is basically that the battery is unlocking new sites if they have a really low grid connection point limit that is approved by the DSO. And that is becoming an increasingly bigger problem for sites that are being opened in the recent times, because DSOs are not able to allocate a larger grid connection point limit, and therefore DSOs are thinking about batteries and seeing how the batteries can basically also try to still effectively ensure a good charging experience with not really curtailing the EVs because we have a lower limit. But here, the virtual grid expansion would basically ensure that if we are at the limit of the demand at the site, like if we're at the limit of the grid connection point because there's a huge demand, normally what we would do is curtail the EVs, but instead here we would discharge the battery so that the EVs can continue to charge at a full speed, and the battery is then catering to this additional power demand that goes beyond the grid connection point.
So with something like virtual grid expansion, this would help a country like the Netherlands, where they are very much kind of maxing out the capacity of their grid.
Yes. So basically, the virtual grid expansion would be a very good feature to have in the Netherlands, because in the Netherlands, the kind of grid limits that they have is quite low. And for charging point operators, it's kind of difficult to operate with such low limits. And that's where, for example, they are starting to think about deploying a battery on site, and that makes it possible for them to still be providing a good charging experience to the customers, because the battery then can compensate for the additional demand that goes above the limit. And that's where I see the virtual grid expansion coming into play. So that's like a perfect feature to have in the Netherlands, because you won't be constrained by the grid limits, and rather use the battery to your advantage.
Yeah, it sounds like a win-win situation.
Definitely.
That one.
Yeah.
And then if you look 3 to 5 years ahead, do you see every major charging site having this kind of storage as the norm, or having virtual grid expansion as the norm?
I mean, in 3 to 5 years, I definitely see that almost every other charging site would have a battery, because I mean, on the one side, there is the grid limitation, because we are hitting the limits, but there's also a lot of traction where the DSOs are also trying to improve the grid infrastructure. So that is still happening on the one side, but I definitely see that with time, the price of the batteries would also go down, and this would ensure that, or this could be an opportunity for the charging point operators to start bringing in the batteries on site. And once you have a battery, then the possibilities are really huge.
That sounds a good stopping point to then head into the rapid fire questions. Who do you trust more with your EV charging schedule, the DSO signal or your calendar app?
I think I'd play it this way, that I would probably trust the gridX EMS, because it takes into account when I'm going to be leaving. So basically my schedule. It takes into account what the DSO signal is, and then factors all of this into account and provides a good charging schedule that eventually ensures that my EV is ready when I want to leave. So yeah.
Do you have a car?
Yes.
Is it an EV?
Yes.
Oh, nice. So then this might answer this question. What is your favorite EV manufacturer?
Um, I mean, it's a tough choice because right now every every automotive OEM is really focusing on EVs, and there's some really good ones out there. But if I have to name one, then I think I would be going with BMW.
Uh, if you could be any home energy asset, which would you be?
Never really thought about it. I think I would be a PV because yeah, I mean, the region that I come from in India, we have a lot of solar. So basically, we have a lot of sunshine all through the day, throughout the year. And yeah, here it's kind of difficult because you also have winter periods where it's like hardly any sun. So if I'm a PV, then I'm probably yeah, trying to get or maximize the amount of sun that I have,
Yeah.
which is good.
What is more terrifying, a surprise DSO curtailment or a fleet manager with range anxiety?
I think it's a fleet manager with range anxiety because yeah, I mean, if your vehicle cannot really make it to the next route or the next planned route, then it is really terrifying. So to really ensure that you have a good um, preparation, it's crucial that they have a good EMS in place that takes into account all of this. So I think it's really the range anxiety part of it, which is quite terrifying.
Bidirectional charging, love it, hate it, neutral.
I think I would. I think I'm still kind of neutral about it. It definitely has a lot of advantages. It does provide an additional flexibility, and this kind of flexibility, when it's aggregated, it provides a huge relief to the grid. And instead of the EV sitting idle, because that's also what the stats say, right? So almost 90% of the time, EVs or just vehicles are parked, and
Yeah.
only 10% of its lifetime it's actually being used. So I would say for such an asset, that's like we can definitely look at it as an asset, like an energy asset, because it's most of the time stationary or is
Battery
just
on
idle.
wheels.
Definitely. So I do see the potential, but then on the other side, I'm also a bit concerned about how the batteries would respond if there is a lot of
Yeah.
cycling between charging and discharging, because we also have to consider the life cycle of the battery. And for a vehicle that you own, you should also be able to um, really have a longer life cycle because it's a huge investment. But if we have a good solution for that, then I think we like my neutral tone would move towards positive, love it kind of thinking.
If you had a magic wand and could change one thing about EV charging infrastructure, what would it be?
I think if that's only one, then it would be about charging EVs as quickly as possible, like really making it as quick as fueling a gas vehicle.
All right. Well, thank you so much for joining me today. I finally understand what DSO signaling is. Had no idea when we came into this podcast.
Yeah, thanks a lot for hosting me and for the nice questions. I think it was definitely an interesting conversation. So thanks a lot.
If you'd like to learn more about the world of renewable energy or energy management systems, be sure to check out our website, gridX.ai, where we produce regular blogs and glossaries about the subject. You can also follow us on LinkedIn or on Twitter and Instagram at GetGridX.